Okay, on question number 1, it says let f be a function graphed above, defined on the domain from 0 to 8, and let g of x equal f of x cubed. And we want to evaluate what g prime is. So g prime of x, we're going to have to use chain rule. 3 is going to come in the front. Inside stays the same. Exponent goes down to a 2, and then times by f prime. And then we're going to plug in 1. So 3 f of 1 squared times f prime of 1. And then we're going to figure out where these values are coming from. So I'm going to use the graph up top here. This is the graph of f, not g. So f of 1 is going to be 3. So I have 3 squared times f prime of 1 is going to be the slope at 1, which rise over run is going to be 1. And so I get 3 times 9, which is 27. You do not have to simplify, though. Alrighty, the next one says let h of x equal f of 3 of x. Write an equation of the line tangent to the graph of h at x equals 1. So x is 1. The y value, we're going to plug 1 into h because we want the tangent line to h. So f of 3 times 1, which is f of 3, which from my table or my graph right up here, f of 3 is 2. So my y value is 2. And then to get m, we got to take the derivative. Once again, is chain rule. So h of x is going to be f prime, the derivative of the outside. Inside stays the same, so 3x stays the same. And then times by 3. So h prime of 1 is going to be f prime of 3, and then times 3. And f prime of 3 is going to be the slope at 3. So the slope here is rise over run, so negative 2. So it'll be negative 2 times 3, so negative 6. All right, and then my tangent line, y minus 2 equals negative 6, x minus 1. All right, find the instantaneous rate of change of j at x equals 3. So we got to use quotient rule because instantaneous rate of change is the derivative. So low d high, which is f prime of 2x times 2, minus high d low, which is just 3, all over low squared. Now remember, we don't have to simplify, but we do need to plug in the x's and evaluate the f's. All right, so I'm going to have 3, x is going to be 3, f prime of 6 times 2 minus f of 6 times 3 all over, and then, oops, hold on. 9 squared. Bless you. All right, so f prime of 6 and f of 6. So 6 is right here. So f of 6 is 1 and the slope is 1. So they're both going to be 1. So my final answer, 3 times 3 is 9. You don't have to simplify that, but this guy's going to be 1 times 2. This guy's going to be 1 times 3. And then 9 squared is 81. So you could stop there, or you could keep going and go 18 minus 3 over 81. I'm going to stop there. I ran out of space. All right, and then this one here, k of x equals this guy, and we're going to do it k prime. So we're going to have to do a product and a quotient rule. So first I'm going to write an expression for k prime. All right, so 1 d2, so 1/2 x squared plus 5 to the negative 1/2 times by 2x. 1d2 plus 2, and then the derivative of the first function, which is f prime of x minus 1, and then times by 1 because the derivative of x minus 1 is 1. All right, so now we're going to plug in. So we're going to plug in 2. So I have f of 2 minus 1 is going to give me 1. 1/2. 2 squared is 4 plus 5 to the negative 1/2 times 2 times 2 is 4. plus 2 squared is 4 plus 5, which is 9. And f prime of 1, and I don't really need that times 1. All right, so f of 1, coming back up here, f of 1 is 3, and f prime of 1 is 1, because it's the slope. All right, so f of 1 is 3, and then 1/2 times 4 is going to be 2. And this guy here is 9 to the 1/2, which is 3, and it's going to be a fraction because of the negative. Plus 3 and f prime of 1, so once again the slope at 1 is 1, so that's going to be 1. All right, the 3 and the 1/2 cancel, so I'm just left with 2 plus 3, which is 5. All right, next one. Let f and g be differentiable functions, and I've got these tables, and I want to first figure out what h prime of 1 is. So I'm going to write an expression for h prime. Derivative of the outside, inside stays the same, times by the derivative of the inside. And then I'm going to plug 1 in. F prime g of 1 times g prime of 1. All right, now we have to work from the inside out. So we have to figure out what g of 1 is first. So we're going to go to my table. G of 1 is 6. So that's going to give me f prime of 6. All right, so f prime of 6, we're going to go to my table. F prime of 6 is 4. And g prime of 1 is 5. And so I get 20. All right, let k equal arctan plus 4x squared. Find the slope of the line to the graph at x equals 2. All right, so we got to first figure out what y is by plugging in 2. Oh, I'm dumb. I don't need the equation of the tangent line. I just want the slope. That's why that doesn't work. All right, so I just want the slope of the tangent line. So I just want m. So I need the derivative. The derivative of arctangent is 1 over 1 plus x squared plus, and then the derivative of 4x squared is 8x. And then we just got to plug 2 in. So 1 over 1 plus 2 squared, which is 4, plus 8 times 2, which is 16. And so you get 1/5 plus 16, which you don't have to simplify, and you can just leave it like that. All right, suppose m of x is a function such that g of m of x equals x for all x on the interval from 3 to 9. Find m prime of 4. All right, so this guy right here means inverse. That's one of those inverse properties. F of g of x equals x, and g of f of x equals x. So you don't have to write this, but if you see that expression, that just means inverse. So I know that this is going to be an inverse type question. So the first thing I'm going to do is I'm going to rewrite m as g inverse prime of 4, and then I'm going to use the formula 1 over g prime of g inverse of 4, and then I can use this information about g from up here. So when I'm talking about g inverse of 4, this guy here is a y value. So when the y value is 4, the x value is 9. So it's 1 over g prime of 9, and then g prime of 9 is 3, which is going to give me 1/3. All right. Let n of x equal f of x squared. If f double prime of 9 equals 2, evaluate what n double prime of 3 is. Okay. So n prime of x. So derivative of the outside inside stays the same, times by derivative of the inside. All right. And then we're going to take the second derivative. So we're going to have to use product rule. 1, 2. So 1, derivative of the second is just 2, plus the second function, derivative of the first, which is f double prime of x squared, times by the derivative of the inside, 2x. And then we're going to plug 3 in. My n's are slowly starting to turn into h's. So n double prime of 3 is going to give you f prime of 9 times 2 plus 6 f double prime of 9 times 6. Oop, I ran out of space. Okay. F prime of 9, we're going to use the table up here. F prime of 9 is -4. So -4 times 2 plus 6. And then F double prime of 9 is given to us right here. 2 times 6. And I'm going to leave it like that because I ran out of space. And so I'm not going to simplify. The last one. Did you finish?
Yes.
Thank you.
Thank you.
All right, so we're going to take the derivative and we're going to show that dy dx equals this guy right here. Now on this first part, we do have to use product rule. So we have the first function. Oops, I'm going to make my pen smaller. All right. The first function, derivative of the second, which is just going to be 1 dy dx, plus the second function, and then the derivative of the first, which is going to be -2, plus, and then the derivative of y squared is 2y dy dx, plus the derivative of x is 1, the derivative of 9 is 0. So anything that has a dy dx is going to stay over here on the left. Anything that does not is going to get moved to the right. So this guy is moving and the +1 is moving to the right side. So that's going to give me positive 2y minus 1. Then I can take a dy dx out and I'm left with negative 2y. Oh wait, is that supposed to be a, I messed up somewhere. Dang it. Oh, that's an x. What am I doing? 1 is just negative 2x. All right, we're back on track. Negative 2x plus 2y is left on the inside equals 2y minus 1. And then I can divide by this whole parentheses here. Make sure you show your work, though, because that is part of this question. All right, so we get dy dx equals 2y minus 1 over 2y minus 2x, which is exactly what they have written right here. All right, write the equation of the tangent line to the curve at the point 1, -2. So x is 1, y is -2. We got to find m. Now, it gives us the derivative, so all I have to do is plug in the numbers. All right, so 2 times -2 minus 1 over 2 times -2 minus 2 times 1. So 2 times -2 is -4, minus 1 is going to be -5. And then I get -4 minus 2 is going to be -6. So I get 5, 6 for my slope. And so I got to write the equation of the line. Y minus double negative is going to turn that to a plus. Y plus 2, 5 over 6, x minus 1. All right, and then the last part here is to find the second derivative. All right, so I've got to use, because remember, dy dx is 2y minus 1 over 2y minus 2x. So we're going to use quotient rule. All right, so d squared y dx squared is low. Thank you. Did you finish?
Yes.
Awesome. Did you finish?
Yes, thank you.
Thanks. Oop. All right. Low, d high. So the derivative of 2y is 2 dy dx, and the derivative of -1 is 0 plus high. And then d low, the derivative of 2y is 2 dy dx, and the derivative of -2x is just going to be -2 all over low squared. All right, so you do not have to simplify, but you do need to go and substitute in your dy dx's. So you could write this as a very long final answer. 2y, which is what I would suggest. I would not suggest simplifying. 2y minus 2x times 2, and then dy dx is the 2y minus 1 over 2y minus 2x. Close, close, plus 2y minus 1, 2, and then dy dx is 2y minus 1 over 2y minus 2x minus 2, close, all over 2y minus 2x squared. And I would not go any farther than that, because if you simplify wrong, they're going to count off. But if you leave it like this, this is good. Okay. And then I will say on the FRQs, they are going to have a question about where is there a horizontal tangent and where is there a vertical tangent. So remember, for the horizontal tangents, just as like a side question, that is when your slope is 0, or you would set the top equal to 0. So in this one, the horizontal tangent would be when 2y minus 1 equals 0. So when y equals 1/2. Hi, and then you find the x by plugging in the y back into the original. All right, and then for the vertical, you would set the bottom equal to 0 and kind of do something similar. Okay, I'm done.